Okay, example 10b. Let's go through this. The average height of male Canadians between the age of 25 and 44 is 176 centimeters. Okay, so this is a population parameter. Okay, so this is information about the population making it a parameter. A researcher at the Canadian Institution believes that they are actually taller than that. Okay, so here they are taller. We know that the sign, the mathematical sign with taller or greater, must be greater than. He randomly selects 100 males. Okay, so this is the sample size, which is n, lowercase n. In this age category, and he finds that the average height of his selection of his sample was actually 177.8, and the standard deviation of the sample, this is S, is 8.1 centimeter. Okay, part A asks us to set up an appropriate test using an alpha of 5%. What inference can we make based on this study? Okay, so here we need to make a decision about what kind of test we're going to run. Remember that the way we decide this is if we have sigma, we should use z or the normal distribution, and if we only have S, the sample information, then we should use a t distribution. Okay, so I'm going to use a t-test. Okay, so the first thing that I should do is set up my hypothesis. Okay, so my null hypothesis and my alternative hypothesis. I am testing averages. Okay, so I want to see if my average is, well, let's look at the sign here. Okay, so the sign that we're looking at is a greater than sign. It doesn't have any form of equality in it, so this should be in the alternative, is the greater than. And the less than or equal, notice that there's an equal sign, so it should be in the null hypothesis. Okay, so what we're testing is if the average is actually greater than 176, or if it's less than 176, and you can include the units if you like, centimeters. Okay, so that's our hypothesis. Let me draw the picture here. We know that a t distribution is symmetric and hump-shaped like this. Okay, and what we're talking about here is the less than or equal to is h naught, and the greater than is ha. We know that our alpha here is going to be 5%. Okay, so this area here should be alpha, which is 5%, and we probably would like to know what value is this bordering this critical value here. Okay, so you can flip to your t table. Okay, t tables are a little bit different than z tables. Notice instead of a cumulative, it's actually a greater than or equal to value. This means that it's giving you the tail probabilities. Okay, anyways, we're looking for this value here. What we need to do on the top is find our tail probability. See, this is in the tail, is 5%. And of course, we need to find our degrees of freedom down on the rows. Okay, remember degrees of freedom for a t-test are n minus 1. And here we talked about the number of people we sampled being 100. So 100 minus 1, not minus 9. 1 is the degrees of freedom, meaning that there are 99 degrees of freedom. Okay, if you look up on a t table, if you go down to 99 degrees of freedom and 0.05, you will find that the value will be should be 1.660. Okay, so this critical value should be 1.660. Okay, that's the test. That's the value that's going to border which hypothesis is actually being supported here. Okay, the next step is to find our test statistic. In this case, we're calculating a t-value. Remember, this is found by x bar, subtract our hypothesized mean over top of the sample standard deviation, which is divided by root n. Okay, so here our x bar is actually from the sample. This is 177.8, and our hypothesis was 176, divided by the sample standard deviation, 8.1, and over root 100. Here we get a test statistic of 2.22. Okay, so we always know that this middle here is 0. Here the bordering value is 1.66, and our value we found was outside here in 2.22. Okay, so here we're clearly in this HA region. So here the data is supporting HA. Okay, which means that we are rejecting H naught. Okay, now we would like to have the p-value. A p-value is a much better way of actually making a decision here. Let's use Minitab to calculate that p-value. Okay, in Minitab, the way that we do this is we go to Stat, Basic Statistics, and here we're doing a one sample t. Okay, our summarized data here, our sample size was 100. Our mean from the sample was 177.8. Our sample standard deviation was 8.1. And we're going to perform a hypothesis where our hypothesized mean was 176. Okay, make sure to click on Options to tell you so you can tell Minitab what your level of confidence or your alpha level is. Remember, alpha is just 1 subtract the confidence level here. So here, if we want to be have an alpha of 5%, then 1 minus 5% is 95. That's good. Also, in the alternative, we need to make sure that we have the sign that we've put into our alternative. Let's just quickly go back and check. Let's look at our hypothesis. Here's the alternative hypothesis. Okay, so here the sign here is a greater than sign. Okay, so this is a greater than sign. Okay, we can press OK. Notice here that we arrive at the same test statistic that we calculated by hand, 2.22, but also here the nice thing about Minitab is it gives you the p-value, 0.014. Okay, oops, sorry. So here we know that our p-value is actually 0.014. Okay, so here if we're talking about the p-value versus the alpha, p-value is smaller than alpha, so we come to the same conclusion to reject H naught. Okay, part B. What type of error could the researcher have made in this case? Well, remember we need remember what we did here. We rejected H. We rejected H naught. Okay. Remember H naught here was that mu was less than or equal to 176 centimeters. Okay, so we rejected this idea. Okay, so let's remind ourselves of the kind of errors. Okay, so our test could lead us to believe H naught or to not believe H naught. Okay, so that's our test. And then we have the truth. Okay, the truth could be that H naught is correct or that H naught is not correct. Oops, move back. Okay, so if our test says that H naught is true and H naught actually is true, no problems there, that's fine. If our test says not to believe H naught and H naught is actually not true, no problems there either. Okay, remember here, if our test says that H naught is true, but in the real world H naught is not true, this is called a type 2 error. Okay, so this is type 2. And if our test tells us that H naught is not correct, and it really is, this is called a type 1 error. Okay, so here we rejected H naught. Okay, so here our test said that H naught was not correct. Okay, so our test, we're putting ourselves into, let's see, we're putting ourselves into this situation. Our test said that we were rejecting H naught. So if we made an error, okay, now we're only in this row. If we made an error, the only error we could have made was type 1. Okay, so since we rejected H naught, the only error possible would be a type 1 error. Okay. At what level of significance would we have reached a different conclusion? Okay. So remember here, our p-value was 0.014. Okay, so here 0.014, this is where our test statistic was. Okay, so we knew that when alpha was 5%, we rejected, but if we decreased alpha, this question's asking how much would we have to decrease alpha before we make a different decision. Okay, so here, if alpha was to be equal to 0.014 or it was less than 0.014, then we would have accepted H naught. We would have failed to reject H naught. Okay, so why did I say it two different ways? I said accepted H naught, or I said reject or failed to reject H naught. And it depends on what kind of a statistician you're asking, which of these is actually better. Okay, so some statisticians say, well, you can't ever accept H naught because that's kind of assuming that you've proved something's true. So some statisticians, rather than say you've accepted something, meaning that something's been proved, instead you can just cover your butt and say, no, I don't accept it, instead I fail to reject it, which really in plain language is the same thing. Okay. Part D, interpret the p-value in context. Okay, so here, remember, what does the p-value mean? Okay, the p-value means that if H naught is true. Okay, so that's important. If H naught was true, then the p-value gives the probability of seeing your given sample. Okay, so remember your hypothesis is about the population. Okay, we're making hypothesis about the population. If our hypothesis about the population is true, then the probability of your sample being whatever it is that you got is known as the p-value. Okay, so what that means in terms of this question here, remember our p-value was 0.014. Okay, so if H naught is true, okay, what was H naught again? If the average Canadian height is less than or equal to 176 centimeters, if that is true, then the probability of randomly selecting 100 people and that sample average was 177.8 centimeters. The probability of that actually happening here is 0.014 or 1.4%. Okay, so what we're saying here is if the H naught was true, if Canadians actually were 176 centimeters or less, then the probability of a sample of 100's average being 177.8 is approximately 1.4% likely. It's very rare. So really what we're saying here is it would be very rare to get this kind of sample. Therefore, what we've done here is concluded that it's likely that Canadians are actually taller than that.